So chapter 7 is all about data and data analysis and data displays. And in 7.2, we're going to talk about one way to display the data. So in 7.1, we found the mean, median, mode, range, standard deviation. Those were all measures for the data. Now we're going to display data in a box and whisker plot. So let's take a look at the top of the page here. The first vocabulary word says box and whisker plot. A box and whisker plot shows the variability of a data set along a number line using greatest values, least values, and quartiles. So let's write that definition down. Box and whisker plot shows the variability of a data set along a number line using the greatest value, least value, and quartiles. So let's talk about what that last word means, quartiles. And that's actually our next vocab word. What is a quartile? What does it mean for us, and how are we going to use it to do a box and whisker plot? So let's write the definition of quartile, and then we're going to actually draw a little picture. So write the definition right here, maybe a little bit smaller, and then we're going to draw the picture over here. So the definition of a quartile, I'm thinking about what the word quartile means. It has quart in the beginning. Quart, like quarter, is 4. So quartiles divide the data into 4 equal parts. So divides data into 4 equal parts. That's what a quartile does. So let's talk about how on a box and whisker plot the quartiles will look. So we're going to talk about 3 quartiles, Q1, Q2, and Q3. So Q1, Q2, and Q3. Q2 is the median or the middle. Okay, so that's how we find Q2. And Q1 is the middle of the lower half, and Q3 then is the middle of the higher half. So hopefully you still have a little bit of room for a picture here. Let's talk about what that looks like on a box and whisker plot then. So we know we're going to use the least value, the greatest value, and then the quartiles, okay? So in a box and whisker plot, we'll have a dot down here. That's going to represent the minimum. We'll have a line going to another dot that represents Q1. A box, hence the box and whisker plot, going to Q3. Well, notice I skipped Q2. That's because Q2 is in the middle of the box, and then another line going out here to the max. So that's kind of what our box and whisker plot is going to look like. In order to make this box and whisker plot, I need 3 things: the minimum, the maximum, Q1, Q2, and Q3. That's what I need in order to do this. So the first thing we're going to do is find those. In order to find the minimum and the maximum, we're basically going to look at what is the lowest number and what is the highest number. But in order to find the quartiles, the different quartiles, I need to put our data in order and then find the middle. So let's go ahead and take a look at this. Example 1 says, make a box and whisker plot that represents the ages of the members of a backpacking expedition in the mountains. So then I have a bunch of ages listed. So if I'm going to find the min, the max, and then the middle of the lower half and the middle of the upper half, I need to put these numbers in order. So that's going to be our first task here. Let's put these numbers in order. Looks like my lowest number is 18. Notice that as I write these down, I'm going to cross them off to keep myself organized. I see 22. I actually see that twice. So 18, 22, 22. And then I see 24 and 25, 25 3 times actually. So I'll write 25 3 times. After that, I see a 27 and then a 28. And then the last 3 would be 30. So I'll write 33 times. So now I have my data in order. That's an important first step if you're going to make a box and whisker plot. You have to have the order and date. You have to have the data in order. Now I'm going to circle different parts that we're going to use here. The first thing I'm going to circle is the lowest value, and I'm going to label it min for minimum. And then I'm going to circle the highest value, and I'm going to label it max for maximum. So those should be the easiest two to find, the minimum and the maximum. Now I'm going to find the middle. I've talked about this before back in 7.1, but I think the best way to find the middle is to kind of work outside in, so cross off or mentally, or actually, if you want, you can actually cross off these numbers, cross off one here, cross off one here, 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 on the left, on the right, and keep going until we get to the middle. Now, I noticed something. The middle is between 25 and 25, so the median, the Q2, is actually right in between there. I have to figure out what's in between 25 and 25. Well, obviously that's just 25, so 25 is my Q2. And then I'll go and find the middle of the lower half. This is the lower half. And then the middle of the higher half, which is up there. So let's find the middle of the lower half, working our way in. The middle is between 22 and 24. What's between 22 and 24? 23. So that's my Q1. If you didn't know what was between those, you can average them. So add them together, find the middle. And then do the same thing on the top over here. I'll go count in one on each side. Looks like the middle here is between 28 and 30. That'd be 29. So Q3 is 29. So once my data is in order, I find the lowest and the highest, the middle, and then the middle of the lowest and the middle of the middle of the lower part and the middle of the higher part. Note that 25 is my Q2 here because it was between these two. If there was a number in the middle, I would circle it and I wouldn't use it for the top or the bottom half. So that's an important clarification. Now I'm going to put dots at each of these. I'll put a dot at 18 for the minimum, dot at 23 for Q1, a dot at 25 for Q2, 29 for Q3, and 30 for the max. Now this is a box and whisker plot. The box goes around Q1 and Q3 with a line through Q2, and then the whiskers go out to the lowest and highest values. So that's what my box and whisker plot looks like. We're gonna try one of these before we get to actually interpreting this. So why don't you guys just find some extra space. We'll call this one extra example 1. If you're feeling good about this, you can just go ahead and try this. If not, just keep listening and I'll go through how to do it. So I'm just gonna give you some data here. Your numbers will be 3, 5, 4, 7, 2, 3, 4, 6, 4, 5. I want you to find or to create a box and whisker plot. So step 1, or again, pause it here if you want to try it on your own, and then you can check it, but I'm going to go through it. So step 1 here is to put the numbers in order. So I'm going to go, I see a 2, I've got 3, 3, I've got 4, 4, 4, 5, 5, 6, 7. So once I have my numbers in order, I'm going to circle my minimum and my maximum, and then I'm going to find the middle. So I like to actually count in to find the middle. There, and there, 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 and I keep going. It looks like the middle is between 4 and 4. What's between 4 and 4 is 4, so that's Q2. And then I'll find the middle of the lower half and a middle of the higher half. So the middle here would be crossing off 1 as we go. The middle here is 3, so that's my Q1. And the middle over here would be 5. So that's my Q3. Now that I have all my values, and I'm gonna actually have to sketch a number line here. So draw a number line. My values are going from 2 to 7, so I'm just going to start at 1 and count up to maybe 8. 5, 6, 7. Looks like I have room to go up to 9. And I'll put my dots. So my minimum is at 2, Q1 is at 3, Q2 is at 4, Q3 is at 5, and maximum's at 7. I'll put my box around my Q1 and Q3, line through Q2, and my whiskers going out to the min and max. So in the next couple examples, we're actually not going to make box and whisker plots. We're just going to interpret box and whisker plots. So let's go ahead and take a look at the next example. Take a minute to write this down. If you didn't print out the notes, take a minute to write this down and then sketch this. So pause it here, write this problem down, and sketch that. So the box and whisker plot represents the lengths in seconds of the songs played by a rock band at a concert. So I want to go ahead and interpret or answer all these questions. Part A says, find and interpret the range of the data. The range, remember, we talked about in 7.1 is the highest or the maximum minus the lowest, which is the minimum. So let's take a look at our data. This is the minimum, which is at 160. This is the maximum, which is at 300. So to find the range, I'll take my maximum, 300. I'll subtract my minimum, 160. That means my range is 140. We're talking about song lengths in seconds, so that's 140 seconds. What that means is that all songs are within 140 seconds of each other. They all range by 140 seconds. And then it says describe the distribution of the data. So I want to talk a little bit about a box and whisker plot. There's a reason that there's a box and there's whiskers, okay? The reason we have a box and whiskers, so let's maybe write this down off to the side or somewhere in your notes, is that when you have, let's just sketch a box and whisker plot here. When you have a box and whisker plot, the box actually represents 50% of the data, and the two whiskers each represent 25%. So in total, there is 100%. That's how it's set up. So when I'm asking you describe the distribution of the data, that's what you're going to tell me. You're going to tell me that 25% of the data is in the lower half, and that's this part between 160 and 220. So 25% is between, oops, that's not how you spell between. How about we try that again? Between 160 and 220. 50% of the data is in the box, so that's between 220 and 280. So 50% is between 220 and 280. And then the last 25% is in this whisker, which is between 280 and 300. So then I would say 25% are between 280 and 300. The next question asks us to find and interpret the interquartile range of the data. Let's talk about what the interquartile range is. So the range we already talked about and we actually found in part A is the max minus the min. The interquartile range is found by taking Q3 minus Q1. So Q3 is the right end of our box right here, so 280. So Q3 is 280. Q1 is the other end of our box in the box and whisker plot, so 220. I'll subtract those two to find my interquartile range, which is 60. So the quartile range, the interquartile range represents 50% of the data. So what that means is that 50% of the songs, half of the songs, 50% of the songs are within 60 seconds of each other. And then lastly, it says, are the data more spread out below Q1? So that's asking this whisker that I just outlined in green. So below Q1 would be in green, or above Q2, or Q3, I'm sorry, which is in orange. So take a look at the green line and the orange line that I drew up here. Green line, orange line. Which one is longer? Which one is a bigger line? The green line is, so my answer is below Q2, because the whisker, there's more data, it's a longer whisker. It's more spread out. Let me go back and repeat that. There's not more data. The data is more spread out. So we'll say the data is more spread out. So we have one more example left in 7.2, where we're actually going to look at the different shapes of distributions of box and whisker plots. So the first thing we're going to do is talk about the 3 different shapes we have, and then what that means. So the 3 different shapes we have are that our data could be skewed left. Skewed left is the first option. We'll draw a picture and talk about that. Symmetric. Or skewed right. So skewed left, symmetric, or skewed right. Skewed left is going to look like this. We're going to sketch a picture of it. It's going to have a longer whisker. Let me make that really obvious. A longer whisker on the left side, a box where the median is closer to the left or to the right, and a shorter whisker on the right. So do you see how skewed left has a longer whisker on the left? That means that most of the data is on the right, because 50% of the data plus another 25% of the data, 75% of the data is over here. This little box only has 25% of the data, this little line, but it's really spread out. So if it's skewed left, a key here is that most data is on the right, okay? So it's skewed left, but most data is on the right. Symmetric is going to be kind of what you think it is. It's going to be even. It'll have even whiskers on both sides with a box that has the median in the middle. So it's going to be pretty even like that. Symmetric is even. The data is evenly spread out. And then our last option is skewed right, which means we have a longer whisker on the right. And if it's if the longer whisker's on the right, that means most data is on the left. So now let's take a look at example 3 and answer some questions about this. So take a minute to pause here and write this down if you need to. And then we'll go ahead and do this. So it says the double box and whisker plot represents the test scores for your class and your friend's class. So your class is in blue right here at the top. Your friend's class is in red right here. Test scores ranging from, it looks like the lowest one 60 to the highest one 100. It says identify the shape of each distribution. So we're going to identify the shape for your class and for your friend's class. So let's take a look at your class, the top one. Would you describe that as symmetric, skewed left, or skewed right? So when we're looking for symmetric and skewed left and skewed right, we're looking at the whiskers. Is one whisker significantly longer than the other? We also look at the box and we look, is the median in the middle? So one thing I noticed is that the median is in the middle of the box. So that leans more towards symmetric, but the left whisker is much longer than the right whisker. So because of that, I'm going to say that this is skewed left. When I look at your friend's class, it looks like both whiskers are even and the box is even on both sides. So your friend's class is more symmetric. And then the second question, part B, says which test scores are more spread out? Well, more spread out would be a higher range. Also looking at the interquartile range. So it looks like your friend's class has a higher range going from 60 to 100. It also has a bigger box going from 70 to 90. There's 20 points in here, whereas this box only goes from 85 to 95. So I would say because of those two things, because your entire range is more spread out and because the box is more spread out, the answer to that question should be your friend's class. So that's it for 7.2 box and whisker plots. So make sure if you need to, you go back and rewatch this video as many times as you need to and get everything taken care of on that.